Okay, 5.5 Ferris wheel notes. A Ferris wheel, you're going to have to read the notes or just follow along. A Ferris wheel, immediately, I draw a Ferris wheel. With a radius of 10, I'm going to put it going straight down. It's 1 meter off the ground. So I'm going to draw on the ground and call that 1 meter. And it says it takes 16 seconds to go all the way around. So I'm going to draw an arrow going all the way around representing the time and saying 16 seconds. So the questions are draw a diagram, graph, how high at 6 seconds, and then how long above 6 meters in one cycle. No calculator. Use a calculator if you want. So the first thing I'm going to do is going to take the period, I'm going to divide it into 4. The reason I'm going to do that is because I know that sine graphs are broken into 4 sections. So when I do my table of values, I'm going to graph x and y. But I'm not graphing x, I'm graphing time, and I'm not graphing y, I'm graphing height. The reason why I don't erase them is so when I'm doing my graph later, I don't have to get confused as to which one's which. And now, due to the 16, the period, taking the period and dividing it into 4 sections, gives you the x increments. So in my table, I'm going to go up by 4, 0, 4, 8, 12, 16. Notice I end at 1 full period. And now, where would I be at 0? Well, I'm going to put a big red dot where I'd be at 0. So in the table of values, at x equals 0, when I get on at the bottom, down here, well, what's my height? Well, look at the diagram. We're 1 meter off the ground, so I'm going to put 1 into the table. Then 4 seconds, that's a quarter of the period. I'm going to be way over to the right. Then I'll be 1 radius and the height off the ground, so 11. Excuse me, let's do that in black. And then 8 seconds in, I'll be at the top in red again. And that will be 2 radiuses, which would be 20, and the height, 21, not 22. And then finally, I'd be off to the left at 12 seconds, and that would be a height of 1 radius, and the height off the ground, 10 plus 1 is 11 again. And then at the end, I'd be back down at the bottom at the same height I started at, off the ground at 1. Notice this symmetrical pattern. Now, that's usually going to happen for the elementary questions. So now I'm going to draw off a graph again. And notice I'm using graph paper, but we're not going to be so careful with it again. So on the x's, I'm going up by 4s, whatever. Let's go up 2 squares, being 4, just because it is very even. But on the y-axis, all I need are the numbers 1 and 11 and 21. So that's all I'm going to put, and it doesn't have to be perfect. Now, I can draw those points from the table of values. So the first point is going to be 0, 1 on the y-axis. The second point I'm going to do at the end is going to be 16, 1. And halfway in between it's going to be 8, 21, halfway in between at the top there. And then halfway in between on the center line it's going to be 4, 11. And halfway in between on the center line it's going to be 12, 11. And then I'm going to draw the graph flat, 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 steep, 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 flat, 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 steep, 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 flat, flat, flat. And then I'm going to say, well, that looks kind of like a graph I know off to the right. And I'm going to draw it. Whoops, that's way too big. And I'm going to draw it 2 squares by 4 squares. And that looks like a cosine graph. I did that so lazily. But it must be a vertical reflection. So what would the equation be? Well, down below, y equals negative, because we vertically reflected. And I remember that I like to do the box model. So I'm going to draw the box around and even put a box line in the center line. And my amplitude is simply the distance from the top to the bottom. And 21 minus 11 is 10, which is also the radius of the Ferris wheel. Y equals negative 10. I already established that I look more like a cosine, or I look like a cosine and not a sine. Then I'll do my period calculation. P is equal to 2 pi over b. Cross multiply. B is equal to 2 pi over p. Now my period, I'm going to do in big red, I'm going to do it above because I have more space, is from the start to the end, which is 16, and I knew that that was my period. So bottom right again, I can substitute 16 in for my period, and I can simplify b to be equal to pi over 8. And I can put that in the location. Then I can say open bracket. Now I'm starting on the y-axis, and cosine usually starts on the y-axis. So we can substitute just the value, and I could say -0 and erase it, or just close my bracket twice. And then talk about the d value in the graph, the horizontal center line, down below, a y value of 11. I'll circle that one in red. So the next few questions, how high 6 seconds in? How high 6 seconds in? Well, I'm going to put the point on in big blue, 6 seconds in. That's going to be about here. And all we'd have to do is put 6 in for t. And then type it in your calculator, or try and do it without your calculator. It's more fun that way. Turns out to be 18.1 meters. Looks pretty good from the graph, around 18.1 meters, as you can see in the notes. Now the second question, how long above one cycle? Well, for some reason you might be able to see some tiger in the zoo at a certain height on the Ferris wheel, only of above 6 meters. Well, we'd put in the line, the horizontal line in the graph in big blue, y equals 6. We would find the two intersections and subtract, because in big blue, for this whole section at the top, that means that we're above, looking at the Ferris wheel above a height of 6 meters. So we'd graph them both. We'd graph y equals the above, and we'd graph y equals 6. We'd find both those intersections and then do a subtraction. And in the notes, take a look off to the right and then try and figure out how to do that algebraically through period change and letting m equal, and then all of the original things that we did with the ASTC graph. But it turns out to be a time of 10.7 seconds. Makes sense. Period 16, very logical. I'm going to give my units 6 meters above. And great. So now let's take a look at one more, a tide. But the first thing I want you to do is flip a couple pages forward if you've printed them off and take a look at the bike pedal question. I cannot stress enough how much I copied the Ferris wheel question, and all I did was change the words in the word problem. But it's exactly the same diagram, exactly the same table of values, exactly the same graph, exactly the same equation, but it's different information, which is kind of cool. So now let's do a tide question, which is a lot more difficult, a little bit more difficult to visualize. But we're going to do the same steps. We're going to draw a diagram, we're going to do a table of values, we're going to do the period. Then we're going to draw a graph, then we're going to figure out what the equation is, and then answer some more logical questions. Okay, let's do a tide question. So we have high tide. So I'm going to draw a little diagram, a little high tide with a little river bank or the ocean floor, whichever. And then high tide occurs at 18 meters of depth or height of the ocean floor, whichever you like. And that happens at 8 a.m. I'm going to use that information in my table very soon. And then I have a low tide at depth of 8 meters later in the day. So the tide is going to fluctuate through the day, going up and down. So I'm going to start my table of values, and I'm going to graph x and y. And I'm going to cross out x and say time. I'm going to cross out y and say height. You could have used depth. I'm going to do the height of the water. And then we want to start at the time they gave. So they gave 8 a.m. and that's going to be 8 in the table. 8 is equal to 8 a.m. And then they say that that's at 18 meters, high tide. I'm going to shrink my 8 a little bit. Whoops. Shrink my 8 a little bit. Now they say that low tide happens at 8 meters. Now I'm going to put 8 meters low tide into the table, but I'm going to skip a line because high tide and low tide, it will be 2 points apart if we remember the quadrantals. And then I know that I'm going to be high tide again 2 squares later. But let's get back to this low tide here at a height of 8. That's 1:24 p.m. 1:24 2:24 p.m. Is that 1.24? No. 24 divided by 60 is equal to 0.4. So in my table, I have to write 1.4. Excuse me. Not only that, but 1 p.m. on the 24-hour clock is 13 o'clock. So in the table, I actually have to put a combination of 13 o'clock and 0.4, the decimal. Then I did a whole bunch of other math off to the right to figure out averages, but if we can't figure out averages by this point, we shouldn't be taking pre-calculus 12. So off to the right, we've done the averages by adding the two x values and dividing them by 2 and getting 10.7. And then either subtracting 10.7 from 13.4 and putting the next value, or figuring out the difference between them somehow, and whichever, I'm going to say what they are, 16.1 and 18.8, making sure the differences between them are always the same. And then in the height, well, what would be mid-tide? Well, they'll be the averages of the height. And 18 plus 8 is 26, divided by 2 is 13. And I'm going to put mid-tide in red in the diagram. Mid-tide at 13 meters. That happens. It goes through mid-tide twice. It's at mid-tide more than it is at high tide and low tide. And then again in the table, I'm going to put mid-tide down below the 8. Excuse me. Another height of 13. Now it's back to grade 8. All I have is a table of values again, like I did with the Ferris wheel question. Again, it's all above, so it's all going to be just an L, and I can mark. So usually, again, graph paper, whichever, I'm just going to mark the important X's. I didn't do it long enough. And 16.1 and 18.8. It's the problem with graph paper sometimes. It's a little bit confusing, but I prefer it. So we have a high tide at 18, so I'm going to mark 18. We have a mid tide at 13, so I'm going to mark 13. We have a low tide at 8. And we start by graphing all the points. At 8 a.m. we have a point at 18. And at the end, at 18.8, we have another point way off to the right. Then halfway in between, we're at our middle point at 13.4 hours throughout the day. At the bottom, excuse me, in black. And then halfway in between, then I'm going to draw my box. And I'm going to solidify all those points in black that got taken away. Then I'm going to draw my horizontal center line. And then I'm going to go halfway in between, and I'm going to go halfway in between. And then I'm going to draw a cosine function. I'm just going to come up with the equation really, really quickly. Y equals, the difference from high tide to low tide is 10. It's a positive because it looks positive. Cosine. I'm just going to talk about it. Lots of the times the teachers are just going to talk about it. P is equal to 2 pi over B. Cross multiply. B is equal to 2 pi over P. The period is the full period for the whole time. And that full period is 18.8 minus 8, which is 10.8. Therefore, 2 pi divided by 10.8 is pi over 5.4. Feel free to follow those steps through the notes. We're shifting 8 to the right. Excuse me, let's use better variables. So instead of y, let's use h. I don't know what I did before. They might dock you for not correcting your variables in the end if you decide to choose those variables in the beginning. Should be declaring our variables, but whatever. T minus 8. And then plus our horizontal center line. 13. All sorts of other types of word problems, like a spring going up and down, or the bike pedal being very similar to the Ferris wheel, or a tan graph. A plane flies overhead, and the angle between the vertical and the plane gets closer and closer and closer to 90, but never actually gets there, approaching a vertical asymptote. Okay, on to trig identities.